Okay, all right. So today, what we're going to do is we're going to talk about constructing a line of best fit, meaning we're going back to scatter plots, but thinking about how to fit a line, like how to fit a line within all that data. Okay, so let's take a look to see how that gets done. All right, let's go. Okay, all right. So today we're going to talk about the line of best fit. All right, so I would think, let me think. I would think that in terms of the study that we had from scatter plot to the correlation coefficient, this is basically the last stop of that topic, but it's also like what the crowning moment of the studies of this particular topic. All right. So, what is a line of best fit? So, by the way, we tend to use linear regression. Seems to be a little bit more professional. Okay. So, in the eighth grade, people use line of best fit, but typically, once you get into the professional realm, they usually use the word linear regression. Okay, so what is it? A line of best fit fits the data, divide the data into two equal parts with the same number of points on each side of the line. Yeah, more or less. A line of best fit can be a straight line or a curved line depending on the shape of the data cloud. Now, typically in the eighth grade, it's gonna be a straight line. Okay, you can have a curved line, not in the eighth grade. What I'm going to use actually, why don't we go back to the example from earlier to make the point? Okay, right? So remember this very first lesson here, right? With the scatter plot, we plot the points. So this is a line of best fit. So if I were to say, look, let me use a different color. All right, what's a good color? I'll use purple. All right, let's say I got a line here, right? So if I were to say, look, I got all these points here, and I want to find a line that best fit the graph, in the old days, it would look something like this. All right. Before the advent of like really the popularity of calculators, I would try to draw a line with the ruler that probably connects as many of these points as possible. Okay. And so in that case, it would satisfy the requirement of the line of best fit. Now, obviously, this is actually not the line of best fit, even by this standard, because I'm not doing a very good job connecting them. But you get the idea that you would have to. Now, in the modern day, with the advent of calculators and whatnot, the goal of this is to minimize the number of points that are furthest from the, how do I say it? From the line itself. So here, right, this is a little bit away from the line, so that's considered to be an error. That's an error. That's an error. The length of the line tells you just how much the error. So this is a little bit of error. This is a lot of error. This is almost no error. So on and so forth. So the algorithm that comes with, and I don't know the exact algorithm, okay? I have to admit that. So in the modern day, with the use of computing powers, the calculator or the computer itself has a formula or algorithm that allows you to draw a line such that it minimizes the error of each of these points from the original line. Okay, I hope I did a good job explaining that. Now, let's fast forward back to today. So in other words, our goal when we look at something like a scatter plot like this, where it's generally positive correlation, right? Because we're not departing from the topic yet, is to draw a line that will more or less fit into this graph. So the line might look something like this, right? And the most important thing is not the line itself, but the equation in the form of the slope intercept form. Okay, and why do we do that? Let me just get this out of the way. Because if you can have this, if you can derive this equation from this set of data, if you can derive your equation from this set of data via a line that goes through these points of the best fit, then you could make more predictions in the future. Okay, so for example, if we're talking about education versus income, right? I don't need to have a point on this graph in order for me to make a prediction. So for example, now, I mean, these numbers are, I don't know, 16, maybe years of education versus like income, right? Maybe, you know, if I need to know, okay, if you have 20 years of education, how much money would you make, right? I could use this, I could substitute the numbers, right, for X, right, in dollar amount. Oh, actually, no, in years, actually. In years of education, and something will come out at the end, right, that tells me the dollar amount. Maybe it's somewhere around here, or maybe it's somewhere around here, okay? So that's what a line of best fit does, okay, in a nutshell. Now, how do you calculate a line of best fit? So in the old days, right, even when I really first started teaching, right, in the old days, right, you would just have all these points. Now this is practically like a perfect -1, right, in correlation. So you would just find a line and you would connect it, and then once you connect it, you would calculate it using this method, okay? And don't get too caught up with this because we're going to use a graphing calculator again. All right, so the first thing you would need to find the slope, right? So you find 2 points, you calculate the slope, right, whatever that is, -1/2, and then you look here, you look for the y-intercept. So you got your y-intercept here, right, 0, 40, 0, 40 precisely, right? And then you just write slope-intercept form. Slope-intercept form, right? The slope was -1/2. Slope is -1/2. Y-intercept's 40. Y-intercept is 40. Now, is this convenient? Yeah, if the numbers fall in the right place. I mean, if you have a y-intercept that's right here, right? That's exactly 40. It's nice to have, right? And it's super easy to just draw a line through it and then write it. But here's the problem. This is basically an approximation. It's not super accurate because one is it's done by hand, and two is that the way you choose the points, it's not as stringent as it should be. Meaning like it, then the equation changes a little bit, depends on who's drawing the line and how they draw it. Do you understand what I'm saying? So this way, it gets the job done, but it's not the most accurate way. Okay, so now this is actually the steps that I found to do the TI-84 calculator. So obviously, I'm not gonna make you just read it. We're gonna have an example. So here's what we're gonna do. Okay, all right. So I'm actually, this part right here, I'm shooting this for the second time because I made so many mistakes on the first try. It's not even funny. Okay, all right. So here we have a table of data, right? Study hours and versus grade. So you can imagine what the correlation is going to be, right? So here's what we're going to do. So we are going to go to the calculator, all right? So now I actually cleared the whole memory out. So I got to go back to mode and change the diagnostics for statistics to on. Go to stats, all right? I'm going to edit the table, and I'm going to put in these values. So 2510423. Okay, 2510423. Yeah. Now 779270. 779270. 6390. 7584. Okay, all right. All right, so okay, we got our data right now. Here's the thing. So if we go back to stat, right? You remember how right now we would have gone to linear reg, right? Ax plus b, slope-intercept form, right? That's all. By the way, I hope by the time we record this, that that I already told you that we're always gonna stick with choice 4, okay? Not choice 8. All right. Here now, here's the thing. So here we got everything that's the same, nothing new from yesterday and the day before. The only thing I would add now is that for store regression equation, we're gonna do something to this. And the reason why is this. Remember this that I just showed you right now, right here? For you to do it by hand, you have to record the slope and the y-intercept, and then at the end, you would have to write that back in, right? Which means, people have to write it, either try to memorize it when they're doing it or writing it into their notebook and try to do it, right? So we're not going to do that. The way, and not every math teacher does this, but I think this method is better, okay? Is we're going to tell the calculator to remember it for us. This is how you do it, okay? So go to vars right here, VARS. I'm going to go to yvars. I'm going to click on function. And I'm going to tell this calculator to pick y1. Now, what does it mean, right? y1, remember y1? If you press the y equals button, it would be y1 also, wouldn't it? Right? So what we're saying right now is this. Hold on. What we're saying is, hey, look, calculator. Oh my God. The people behind me, I can't. Man, people have a very, very short temper today. That's all I got to say. All right. So what you're telling the calculator is, hey, calculator, where y1 is here from this button, right? Store all that information for me. What are they storing? They're storing the slope and the y-intercept for us. And they're going to put that in as an equation for us. They're going to do everything for us. That's why I want to do that. So I'm going to click 1. So you see that? Now they're going to store y1 from the y equals button, right, for us. And then we're going to calculate. Now, here we got our slope, right? Ax plus b, right? Slope is 6, y-intercept 64. And the correlation is almost 1, right? As predicted. Now, look at the graph. It's not a good-looking graph. Why? Because the y-intercept is so high that it's all the way up there. So I need to manipulate the window a little bit. So here's what I'm going to do. I'm going to go to the window, and this is good exercise for us. I'm going to go to y max because look back at the graph. I don't need any of this space here. So that means I don't need any negative y's here. So here, y min, I'm just going to turn to 0. That's it, because I don't need it. Now, at the same time, let's go back to the graph, okay? So I'm going to go back and forth a little bit just to show you. You see, like this is 1, 2, 3. So that's the y-intercept of 64 is like way up there, okay? So I need to add more room up there, add more room for my y max just to reach that height, okay, of the graph. Now, let's see, let me graph. So sometimes these things, so in other words, what I'm trying to show you is sometimes these things, you actually just got to play around with the graph a little bit. Now, I'm going to change another thing. I'm going to change the scale because I don't like the scale. Going up by 1 is like very painful. So I'm going to change it to 5. I don't know how much that's going to help. And I'm going to change this to 5. Let's take a look at the graph. Yeah, it's a little better. Now, this gets even better. So now I'm going to plot the points from the original table onto the graph so you can see everything at once. All right, wouldn't that be nice? All right, I go to stat. No, wrong. Stat plot. Second, right? Y equals, see the little button right here, stat plot. I'm going to turn the plot on. So I'm going to press enter. Where is this on? On. What type do I want? I want this one right here. I want the scatter plot, right? Because that's a line graph, that's a histogram, so on and so forth, right? So I'm going to press enter, and now I'm going to graph. Watch this. Isn't that nice, right? It's got all the original points plus the line of best fit, okay? And it's the most accurate one that we could find, all right? Now, what's the equation? Let's go back to the equation because I do want to. All right, so 6x plus 64, right? Let's write that here. Y equals to 6x plus 64. And so if you study for 6 hours, what grade can you expect? Actually, you can just plug it in. You don't even need to look at the graph. Okay. Right. So 36 plus 60. Is it 100? Is that right? Yeah, that's 100. Right? Nice. Okay. Could this line go on forever? No, because you can't get more than 100. I also want to ask you, this is a huge question. Huge question. What is the y-intercept good for? What does it tell you here? Think about it. Yeah, if you don't study, let's go back to the graph. Right here, if you don't study, what do you think you're going to get? Yeah, 64, all right? Maybe it's not a good message to send that if you don't study, you'll still pass the test, but that's what that means, okay? So, and then what does the 6 mean, right? Slope, for every hour you study, expect a 6-point increase. Okay, so I hope you understand. And then the correlation is 0.99, right? So let me wrap this up. What it's saying is this: the y-intercept tells you if you don't study, what you're gonna get. The slope tells you for every hour you study, expect a 6-point increase. I should put the +6 here, right? And then the correlation tells you just how strong the relationship is between studying and your grade. It's almost lockstep. Okay, so that's how good it is. Okay, all right, that's it. Thanks for watching, and have a good day. And I'll see you guys back in class. Okay, bye.
OMG, that was so good.